All right, ladies and gentlemen, let's take a look at our last polygon that we're going to look at for this chapter, and that's trapezoids. So our goal today is to find the area of trapezoids. So when we take a look at the definition that we have here, the vocabulary, it's the height of a trapezoid. And so once again, it's kind of similar to what we had with the height of a parallelogram, the height of a triangle. The height of a trapezoid is not necessarily one of the sides. It's the shortest distance between the bases of a trapezoid, which means it's going to be perpendicular to the two parallel sides, just recalling the vocabulary from a trapezoid, so that the height will be inside the trapezoid, unlike the triangle or the parallelogram. It'll always be a distance between those two, but it is not always going to be one of the sides of the trapezoid. So now we need to take a look at, we want to label base 1 and base 2 because there's two parallel sides on a trapezoid. We don't necessarily have just one base. And then we're going to label and draw in, if necessary, the height. So if we look at the first one, we've got base 1 and base 2. Nothing special where I put the 1 and 2. And now what I'm looking for is a perpendicular segment to distinguish the height. Well, none of these segments that are on here meet at 90-degree angles, so I'm going to have to draw in one, and here's my height. Here we've rotated it, so now base 1 and base 2 are left and right instead of top and bottom. But once again, if we look, there's no 90-degree marks in any of the corners, which means none of our sides are meeting at 90 degrees. So I have to draw in a perpendicular segment, and it makes this our height. So we're looking for our bases by looking for our parallel segments. So base 1 and base 2. And the height is where we find our 90-degree angle. Well, right here is our 90-degree angle. And so the side that makes that 90-degree angle, the segment that makes that, that's our height. So in our third example, we see the height is actually one of the four sides of the trapezoid. So we're supposed to fill this in with always, sometimes, or never. So it says the bases of the trapezoid are blank parallel. Are they always, sometimes, or never? Well, this is always. So that's the easy way to find base 1 and base 2, is they're the two ones that are marked parallel to each other. The bases of the trapezoid are blank congruent. Bases can never be congruent because that means the sides connecting them would be parallel. So this is never congruent. The bases of a trapezoid are blank the sides of a trapezoid. The bases are always the sides of a trapezoid. You have to have two parallel sides, and so because the bases are your parallel sides, they're always sides of the trapezoids. So now we're going to start talking about this height. The height of a trapezoid is blank a side of the trapezoid. Well, what we can see is not here, not here, but yes here. And so because we said yes one of the three times, we'll say that it's sometimes a side of the trapezoid. And then it says the height of a trapezoid is blank perpendicular to both bases. Well, we only have a 90-degree angle drawn in here, but what we know is that these two angles have to add up to 180. So if it's 90 here, it has to be 90 here between those parallel lines. The same thing here, if these are same side angles between the parallel lines, then this has to be 90 degrees, and then this would have to be 90 degrees. So the height of a trapezoid is always perpendicular to both bases. All right, so we're going to take a look at the area formula. We did a little bit with this in class, and so we should be familiar with it. But it says the area of a trapezoid is 1/2. That means we're using two trapezoids to make some other shape. It's 1/2 the product of the height. So that's why it was so important for us to be able to identify height, and the sum of the bases. And so now that we've done some of that algebra and area worksheet, we should recognize this formula. Symbolically, it's going to be 1/2 of the height, so 1/2 times the height, and the height is multiplied by the sum of base 1 and base 2. So we're going to have a little bit of order of operations that we have to do here. in order to get our area. All right, so let's find the area of a trapezoid. So they give us a base of 6, a base of 8, and then this is 5. I know it's kind of hard to see in my diagram, but hopefully you can see it in your book. It's 5 inches. So we're going to fill out the formula, 1/2 height times the height times the sum of the base 1 and base 2. So we're going to substitute 5 for height, 6 for base 1, and 8 for base 2. So here goes my 5, here goes my 6, and here goes my 8. My brain's getting a little ahead of my mouth. You're going to simplify within the parentheses. That's the order of operations. So 6 plus 8 is 14. And then simplify that multiplication. So if you want to do half of 14, because that's easy for you to do in your head, and call that 7, that's great. So 7 times 5 is 35. If you want to do 1/2 times 5, which is 2.5, and then do 2.5 times 14 and get 35, that's awesome. If you just want to check this straight into your calculator, either way, we need to get 35, and this is area, so we need to get inches squared. Guys, we really have to work on that. We have to make sure that we're recognizing squared units as being our label for area. So the area of this trapezoid is 35 square inches. So you have some checkpoints to do. You should be able to see all of these. This is 7. This is 14, it's the actual side, and there's your 90-degree angle. And then this one that they have here is 5 for the 90-degree angle. And so your job is to do now, all right, for full credit. So if you forget, if you don't do them, your video points will drop down. But I want you to use that formula, area equals 1/2, and it's right above the checkpoints in your note-taking guide, times the height times the sum of base 1 and base 2. All right, so once again, what that's going to look like is we're going to have 1/2. We're going to plug in the height, which was this perpendicular segment, so 1/2 times 7. And then we're going to keep our parentheses, and we're going to add base 1 and base 2. It doesn't matter which one you call base 1 or base 2. 7 plus 11 is 18. And if you called it 11 plus 7, it would still be 18. So you're going to have 1/2 times 7 times 18. When we multiply that together, we get 63. We need to have our units. So that's 63 meters squared. So pause the video, do 2 and 3 so you can get full credit for your homework. All right, so just like you guys would have guessed, now what we want to do is use the area. We're going to find one of our segments, either a height or one of the bases. So we know it has an area of 96 meters squared. When you know what your area is, that's what you're going to do. You're going to take your formula and you're going to substitute 96 for A. So 96 goes here. We're then going to plug in 8 for the height, and then we have base 1, and that's 9. Now, I do things a little bit differently, and so I typed up my notes different than what's in the note-taking guide. I think this fits with what you guys know how to do. We're going to multiply each side by 2. Okay, because that's what we recognize from the triangles. To get rid of the 1/2, you multiply by 2. That's the only time you multiply by 2 is if there's 1/2 in your formula. So you're going to have 192 is equal to 8 times 9 plus 92 plus B2. Then you're going to divide each side by 8. You're going to divide by that height. So we're going to take 192 and we're going to divide by 8, and what we're going to get there is 24 is equal to 9 plus B1 plus 9 plus B2, and then we're going to subtract 9 from each side. And so when we take 24 minus 9, we get 15. We have to make sure we're putting some labels with that, so that 15 is going to be 15 meters because that's our unit. And so the value of B2 is 15 meters. So it looks very similar to what we were doing. Multiply by 2, divide, But then we have to remember to get base 1 or base 2 by itself, so we have to undo this adding. So it's kind of like you work through the formula to what you need. So we've got a checkpoint here. Let's take a look. We'll do one together, then I'll leave you guys on your own. We have to find the height. Actually, I might do 2 of them with you. So let's take a look at what it looks like to find the height. I'm still taking my formula. Area equals 1/2 times the height times base 1 plus base 2. And I'm going to plug in what I know. I know the area is 77 feet squared. It says A equals. I know I always have 1/2. I don't know what H is. And so I have 8 plus 14 for my bases. Hopefully you guys are looking at this and going, add 8 and 14 together. Simplify. Exactly. I'm not doing any solving here yet. I'm just going to take and multiply or add 8 plus 14 and call it 22. Well, now it looks so much what we had before. Multiply by 2. I'll try and move everything up. Oh, that's not what I want to do. Try and move this up a little bit. $77 times 2 is 154 equals H times 22. And then when I divide by 22, I get H is equal to 7 feet. So solving for height looks a little bit different because we can actually add the bases together. So let's take a look at what it looks like when we're solving for base 1. I'm going to take area equals, so 39, I'm plugging that in for area, equals 1/2 times the height, which is 6, times base 1 plus base 2. So I'm plugging in what I know from that area formula. You're using area equals 1/2 times the height times base 1 plus base 2. So now we're going to go through the steps that we did. Multiply by 2 to get rid of that fraction. So we're going to have 78 is equal to 6 times B1 plus 8. We said divide by 6. And 78 divided by 6 is going to give me 13 is equal to base 1 plus 8. And now we're using our algebra. We undo adding by subtracting. So we're going to minus 8. I'm running out of a little bit of room here. But it says B1 is equal to 13 minus 8 is 5. Get your label in there. And that's 5 centimeters. So you are going to do 6 and 7 now. So these are due now. All right? And that's the only way to get full credit is to finish those. All right? So we'll check those 4 checkpoint columns I left you with. 6 and 7, and I believe I left you with 2 and 3 also to do. And we'll see you guys in class tomorrow.